हेलो। हाँ जी सर, क्या हाल है? हाँ जी हाँ। हाँ जी सर, मैं आपको करूँ 1 घंटे तक, अगर अर्जेंट नहीं है, मेरा अटल सेशन चल रहा है एफटीपी का, है ना? हाँ जी, मैं करता हूँ फिर आपको। हेलो। हाँ जी नेहा। हाँ जी हाँ जी नेहा, हाँ जी। अच्छा, तो उसमें तो कोई अभी इंटरकनेक्शन तो नहीं होगा कुछ? ओके ओके ओके, नहीं ओके, तो अभी मैं क्लिक करूँ, कैसे करूँ? हम्म, तो मैं वही जा रहा हूँ। अभी मैं क्लिक कर रहा हूँ।
uh, CP when he is still in Hong Kong. And these are the various software you know. But what I would like to tell is you become master. See in the right side, nowhere method of line is written. So some of you can, four students, four research scholars join together. You will write wonderful programs. Method of lines, no commercial software has come. You can start it. Galerkin's method, board matching method. So all those things you can try, so that even if you don't have facility with a small MATLAB and the knowledge of this numerical techniques exclusively for planar technology, you can do wonders. Uh, so all these things one should get accustomed. So the best book, one and the only book is Ito book. There is another book edited by Sorrentino, and this is the reference, first reference. We have got living goddess, microwave goddess in India. She is being worshipped by all the microwave people in the world, and she is nobody other than Professor Bharati Bhatt, whom you can know much more if you open Wings of the Fire, written by Dr. Kalam. This book, it is the title is strip line like transmission line, not microstrip, not CPW, anything, any in that family, strip line like micro transmission lines, only 20 pages. That pages, if a person is thorough, microwave circuit theory is in his packet. So this is the first reference book, not for India, throughout the world, to know multi-layer structure, initial microwave circuit theory needed, filters, mixers, whatnot. And this is not for exam point of view. This works in corporate offices. This is one of the reasons why we won Kargil war. Many of the things, whatever works, that came as a book. Whatever is in the book, that works. Some more books she has written, that you please follow. So let the students not have a shortcut directly going to the software. So finally you may not know what is the small things even. So go from the scratch. Maybe 3 months, 4 months, one have to spend. Then finally, whatever you know, you will tell the reason. No trial and error method. So this is first reference. And why to go for planar transmission lines? First of all, miniaturization. You can simply print it. many more things. Recently, India acquired Rafael. Why Rafael is slightly different? Because the enemies cannot see, but we can see. My own student, I will show him. He has developed. He is number one in the. Is number two in India. Number one in the world is Monk.
तो
Monk
मेरा
is
भी
the one. He also developed what Marconi has developed. What
बस
Marconi developed around 200
बात
years before
ये
as a
कैन
patent, that was developed by Monk,
कितना
and that
करे
is
आपको
the
efficiency
hottest field called frequency selective surface. It can directly can be kept in the DRDO.
कितना
Wonderfully, you can
ये
say it is flexible. You can you know the nose of a fighter aircraft. So that nose, it can accommodate. What more flexibility you need more
वो
than that?
डॉक्यूमेंट में क्या
I'll just show the success story of one person about the FSS, and these are all the reasons why to go for a planar transmission line. That is the reason why whenever our ISRO people launch 99, 100% success, because the weight is very less. That is because of the planar transmission line.
तभी उसमें
40% of the circuits are micro integrated circuits, which are based on strip line, micro strip, slot line, fin line, many more variants. It is not only 5 planar transmission lines, 72 planar transmission lines are there. Variants. See, you know very well, the best antenna is the one which uses air as the substrate, parabolic dish, nothing to
वो
equate
ठीक है
to
आपका
that.
2 मिनट के लिए
But
मैं
can you
आपको
think
मिलता
of
हूँ
parabolic dish as the
अभी तो कोई सुन नहीं रहा
microwave pills? Can you
मैं
have the
आपको
dish in the
एफिशिएंसी
satellite?
करता हूँ
Will it
फिर
get
हम
launched?
आपको उठा
So
लेंगे
you need miniaturization. Then only planar transmission line, which is volumeless, which is very light. It can be printable. It is printable on the surface of the fighter aircraft. So that is the reason why we go for planar transmission line. Necessity is the mother of invention. 1935 to 45, many things came in microwaves. Till that time, microwaves are wartime secrecy. Afterwards, now every place, every packet is microwave is there. Microwave oven is there. In 1950, small devices, read diode, impad, trap, all those things came. How to integrate that with waveguide? Then only SB Kahan, he felt the need. So he took a coaxial cable, unfurled it, and that is the starting point for a strip line. It came in 1951, Barrett and Burns. The next year, Eagleman, he found microstrip. In 68, SB Kahan, he contributed for slot line. The next year, CP when he found CPW. Then this slot line, somebody wanted to keep inside a waveguide. That's what NITTTR has done in 1972. That is called fin line. Fin line has been contributed by NIRS, but the person who has contributed the theory to the world is a lady Indian by name Professor Bharati Bhatt. The fin line is the book followed by throughout the world, and that did not come as a book. It came as the outcome of the research work carried under her. So why I keep telling the author's name is, whichever planar transmission line you take, that book you take, the real book, not like a mark scoring notes like book, the authority book. So whatever I have shown are authority books. You take it, go into deep, and you are the master in that subject. So fin lines is there. These are the 5 planar transmission lines. But you know, if you use air, there is no loss. But if you use substrate miniaturization, then but loss is there. So if you want to have both the advantages, air plus substrate use, that is the technology behind micro electromechanical system. Many of the things you can have so many variants: inverted, suspended, V groove. So every planar transmission line, six variants. So like that you combine. If you want to have one advantage, you have to forego some other advantage. So that way you combine many things. That is the principle of micro electromechanical system. That way there are around 72 planar transmission lines available. I will just give an overview in another few minutes. And this is the few technology, planar transmission line, hybrid, and mainly it is done by photolithography. You draw the layout, multiply by 1,000 times, make a photolithography, then reduce it. And now advanced CAD technique also is there. Whatever advanced techniques come, nothing can beat conventional. See, because of this online class, I am not able to see you, you are not able to see me, but every one of you will agree nothing can equate blackboard writing. So that way, things have come, but conventional is the best. So that way, this all came 1952. So regarding the planar transmission lines, one need not mug up its property. What one should know is to which mode it belongs. If you take microstrip, it belongs to quasi-planar, quasi-TEM mode, and strip line, if you take, it is a TEM mode. And one should know what is TEM. It is not always the wave moves in Z direction. Whichever way it moves, perpendicular to that is said to be TEM. So then you have got non-TEM. Slot line is the example for non-TEM. Then combine of E and H, hybrid mode. Fin line is the example. Like that, there are many modes. If you know to which mode each planar transmission line belongs, then you will not forget the property and you will know where to apply and for which frequency. So these are not the history. In microwaves, nothing is history. Like Gitanjali written by Rabindranath Tagore, it is always fresh. What I mean to say is, what Marconi found so many years before, that only is the present day technology FSS. Nothing can replace. Can anything replace magnetron? Magnetron is magnetron. For that purpose, magnetron is the only solution. In the laboratory, you cannot have magnetron. You can have only reflex klystron. TWT, when one is found, previous thing will not go out. It is always fresh. So this is not history. This is a thing that will continue forever. And that's why I keep telling, not like low frequency, where many things have become obsolete. So this is a few overview of when it was found. When we around some 70 years before microstrip was found, now only it has become popular. The main reason of not becoming popular is no measurements lab. So that also exists. Secondly, our students are afraid of vectors, divergence, curl, and all. Now I can prove that without Maxwell's equations, I will now show an equation which you all know, but many of you may not know the importance of that. That equation is sufficient to go for the any design of the component, any design of the circuit, or whatever it is. So that is sufficient and not Maxwell's equations. So Maxwell's equations are needed for full wave analysis, not for the design of the components. I welcome the participants to give your opinion on this controversial statement. I will also show that equation. You all know it, but you may not know how important that equation is in designing. So this is what one should be, especially the freshers. They should know the cross section, and also after cross section they should draw the field lines, E line, just like an electrical machine. From positive to negative you draw the E line, then dotted line H line you put perpendicular to that. So that way you draw the cross section. In the strip line, top and bottom are ground line, center is the strip line. Center is the strip line, and this supports pure TM mode. The disadvantage is, if you want to connect any component, you have to put via hole and then connect. That's why strip line is not as popular as microstrip, but it is a homogeneous material, whereas microstrip is the very popular one. Now it has become saturated. Now no one should attempt to do any research work on microstrip. Books have come. It is fully saturated. So this is supporting quasi-TM mode, and you can see the structure because of the some of the planar some of the fields are in the air, some are in the dielectric. Then slot line by S.B. Cohen. There is no ground at the bottom, and there is a slot. And slot line and coplanar waveguide all belong to the same family, in the sense there is an elliptical polarization. Because of that, you can make use of this for millimeter wave monolithic microwave integrated circuit, MMIC, and ferrite components, non-isotropic, non-reciprocal component also you can join. So in any case, among the transmission lines, if it is millimeter, one should go for coplanar waveguide fin line. If it is a lower microwaves, then go for strip line and microstrip. Then how good it is, that can be determined from tan delta. You say loss tangent. Then there are some materials exclusively for microwaves, like RT durite, then alumina. Each has got some advantage, disadvantage. Then students like FR4 because it's freely available and cheap. And when you go to micro electromechanical system, gallium arsenide, silicon, where the epsilon R is becoming 15. The epsilon R of air is 1. Epsilon R of brain is 50. That is why one should not use the cell phone more than 6 minutes per day. Anyhow, it's all left to the students, but these are all coming under the biological effect of microwaves. Then another thing, so cross section is important. Then field
excuse
line.
me, sir. Raghavan,
Yes,
sir,
yes.
is there any other screen pop up on your screen?
Okay.
If you can just close. Yes.
Now is it okay?
Yes,
Okay.
sir.
Please remind me. Something it has come up. Okay, sorry.
Yes.
Now, when you take up any transmission line, first thing you should know is what is the low impedance, what is the high impedance it can support. Microstrip and strip line are like brothers. Both will have Z low as 20, Z high as 100. Whereas if you go for fin line, Z high is 400. Whereas if you go for image line, Z low is 200. Because when you start designing the component, low impedance, high impedance, that's what people say stepped impedance method. If it is low impedance, you will take 20 ohms. If it is a high impedance, you will take 100 ohms. That is corresponding to inductor and a capacitor. So everything you should know. You should know what is the low and high for every planar. This is not the only planar transmission lines. As I already told, 72 planar transmission lines are there. So I will go to the next one. So this is the one. If anyone is strong in this design, every other component are master. This is a low pass filter. It is a 50 ohms line, 20 ohms and 100 ohms. So 3 capacitors are there, 2 inductors are there, 50 ohm is there. Then what you see right side is the band pass filter, coupled line. First of all, one should be thorough with Z0. Then only you can enlarge it to ZOO, ZOE. So these two filters, if they know the circuit theory, amplifiers, oscillator, antenna, whatever may be the configuration, designing is very easy because there is no element or component other than inductor and capacitor. So one should be thorough. And so incidentally, I would like everyone, if not already consulted, you should see Microwave 101 website. For everything you will say why, when, where, how, you will get the answer in Microwave 101. Why K band is called K, Q, Ka. Anything what we say, if you want to know why, where, wonderful website at Microwave 101. If you also come out with some new things, you intimate, it will be uploaded. Then another application note 154, 30 pages application note, that will tell everything about S parameter, micro amplifier, all types of Smith chart. So now you can see broader line will give capacitor, narrow line will get an inductor. And why 50 ohms? Again, you can see the website. It is the optimization between the attenuation and the maximum power. That's why 50 is chosen as the geometric mean of 70 and 30. So if you take a microstrip, you have got nomogram, especially if you look into the journals of IRE. All the classical papers have come. You should see the Wheeler's diagram. And that diagram only will tell you that higher the frequency, lesser will be the width. Lesser the frequency, higher will be the width. That is how one will design. Isn't it? After all, out of length, width, and height, one has to design only length and width. Height is a manufacturer's concern, 1 by 16th of an inch. Length is concerned, it is all in lambda g, which is equal to lambda naught by root of epsilon effective. That will take care of all the planar transmission lines. If you want to use fin line, use that epsilon effective. If you want to use strip line, use epsilon r, so that if you know the design in terms of lambda g, it is not different from each of the planar transmission lines. If you know the impedances, ZO, ZOE, ZOO, you can find out what is the width of that. So if you know width and the length in the design, what else is needed? So the design is paka, and you can do the fabrication. So the best book, Bible for filter is Mathai Yangan Jones. And these are the substrates. Substrates also very important. When you heat the chicken in a microwave oven, that epsilon r, if you take a man and woman, each part has got different epsilon r. That is how biological effect of microwaves are developed. There is only one and the only book of that kind for biological effect of microwave written by Indian, and the guide of Balvinder's guide. Balvinder guide, his guide is Dr. S.S. Patnaik. His guide is O.P. Gandhi. So his book is the Bible to know biological effect of microwaves. So in any case, whatever I am showing, those are the substrates. Again, there's a book about biological biomaterials, again written by an Indian, M.T. Sebastian. That is the book Bible for materials. One should not simply ask, sir, what is the material for biomedical antenna? What is the material for textile antenna? You should refer that material book thorough in that, especially for biomedical application. It is to be swallowed. It should not get interacted, biocompatibility. So one should go thorough with the respective Bibles, make oneself thorough, and then become master and become real doctorate, not a shortcut method of putting some unwanted journal papers, paid paper, all those things. So that way, so this is the substance used exclusively for MICs. Likewise, substrates. Now our Indian people, MTRDC, Siri Pilani, they have come out working with material gallium nitride, not gallium arsenide. So those are all for MIMS. Likewise, as you go, now Dr. Amalend Patnaik will talk about graphene. Graphene also recent material. So depending upon the frequency and application, you keep choosing the proper one. But you should know everything about it and avoid the shortcut method of finishing the PhD. That will be nice for the society also. And everyone, if I ask my students, which is a better metal for the microwave, immediately they will say gold. Gold is not the one. Silver has got better conductivity. So because of the total internal reflection, silver waveguide is better, and it should be coated with gold. So it can withstand in any polar forms. So that way materials needed, because of the skin depth only, waveguides will be of no use after some conditions. Then you go for ICs, MIC, and planar transmission lines are the backbone of MIC. And these are the advantages of the strip line. First advantage, it is a homogeneous material, but the connecting component is very difficult, whereas the disadvantage is the connection of the component. Whereas you can see that ZOE, ZOO will become same in strip line. So only we go. Now this is the one. I am showing this. See, this is the equation for all the planar transmission lines. What you should do is, suppose if I say non-radiating dielectric waveguide, what is phase velocity? All these expressions you will get for non-radiating dielectric waveguide if you substitute epsilon effective of that NRD. If you want to get the same expression for strip line, replace every epsilon effective by epsilon r. So that's all. So it is, the microwave is not a difficult one. It is a child's play. One should understand it. Then you can, people can design with liking. You can enjoy designing. It is not different, because in Smith chart, one circumference is equal to lambda g by 2. You take that equation, put length L is equal to lambda g by 2, then the equation one will get is z naught is equal, z is equal to zr. If you put lambda g by 4, you get z naught square is equal to zs into zr. If you give lambda g by 8, modulus of z is like that, 0 to lambda, so many infinite lambdas are there. You put all those lambda, then you will know what is its property. So that way, as long as you know in terms of the mode of propagation and also in terms of lambda g, designing any of the component in microwave or millimeter or textile or anything, wearable or whatever it is, the material and frequency is different, but epsilon effective or epsilon r remains same, lambda g remains same. So the design is not at all difficult at all. You can make the microwaves easy. And still now I have not talked about Maxwell's equations. I won't talk also. I will show the equation. But see, in the previous equation, if you put epsilon effective, epsilon r, that is the equation for strip line. If you put epsilon effective for coplanar waveguide, you put that. If it is GCPW, ground support, for that if you want, you put that CPW. And one more thing also you should know about the dispersion. When there is a linear relationship between frequency and beta, at some frequency, only in microstrip, it will have a linear relation. Afterwards, it will bend. That phenomena only is called dispersion. If dispersion cannot be tolerated, you should go for full wave analysis. Otherwise, by calculator, you can finish it off, quasi-static analysis. So that is how it will get. So this is the curve. In strip line, epsilon r will take care of. No need of drawing families of curves. One single curve, this will tell you for any z naught into root of epsilon r, you will get from this curve. You can see higher impedance will have a lower width, lower impedance will have a higher width. This is also like drooping characteristic of a Wheeler's curve. This is not told as Wheeler's curve, but for microstrip, similar curve is called a Wheeler's curve. There, for each of the epsilon r, you should draw it. And these are the coupled line. You know, from reality, husband and wife, you say couple. If both have same liking, it is called even mode couple. If one thinks east, another thinks west, it is called odd mode couple. Same way in microwaves. Whenever two lines come, we say coupled line. If the amplitude, phase are same, it is called even mode couple. If both are different, then it's called odd mode couple. Even mode, magnetic wall, open circuit, these three should come together. Odd mode, short circuit, and electric wall, these three should come together. Then the computation will become easy. Computer will understand, man will understand. So for each of the person's convenience, you need electric wall, you need a plane of symmetry, then somebody odd mode, even mode will be helpful. For circuit theory computation, open circuit and short circuit. So one should not forget that odd mode, short circuit, electric wall, even mode, magnetic, open wall. That way you can do the coupled analysis very easy. That's how your coupled bandpass filter come. If it is a broadside coupling, it is a bandpass filter. If it is inside coupling, it is called bandstop filter. You can design. And this is the equation. No need to remember about this equation. Using this equation only, one will draw the Z naught was W by H. So again, one should not go for calculator, strip line calculator. It is just like a small boy, LKG boy, not reading tables and go directly to the computer calculator. Then finally went to know what is 2 into 2. So that way, one should not go to the calculator also. You take all these things from the Bibles, from the reference papers, you get these equations. Elliptical integral can be made as the summations. So that way, this is just to show the slide, just to have an idea I'm showing. So this is the simple comparison. All epsilon effective replaced by epsilon r, you will get the strip line one, homogeneous. This is the same thing with reference to CPW, all other Babji, all other planar transmission lines. And field lines are very important. This is the field line for slot line, non-TM mode, positive to negative. That's how you draw the E line for the for electrical machine, same thing you follow. E vector, H vector is not different from what you see for electrical line in the uh, electrical machine. So this is the famous coplanar waveguide. It is not a waveguide. Planes are in the same. So it is a coplane. Left side, right side are the ground, and center is the signal point. Especially those who are doing work on flexible antenna, variable antenna, take a coplanar waveguide, support it with ground supported coplanar waveguide. So many advantages. GCPW is the prominent planar transmission lines for flexible, variable. Not only that, nowadays people talk, at least for fashion's sake, IoT, 5G, 6G, without knowing its effect on the health effect. But there also, GCPW is one of the prominent planar transmission line. This is the summary of the planar transmission line's property. One need not bother about it as long as one person knows strip line is pure TM, fin line is a hybrid mode, microstrip is a quasi TM mode, slot line is a non TM mode. Like that, you categorize to which mode it belongs to. This is some more thing. What you take is, you take a microstrip, suspend it. That means you will get the advantage of air, you get the advantage of substrate. So the loss will become lesser. Then you can even invert it. In one case it is epsilon r to 1, in other case epsilon r plus 1 by 2 to 1. Likewise invert it. V grew only two persons from Tyagaraja College, they only introduced the V grew for the whole world. So that way, if you see the R.N. Simon's book, two persons' name, those were all my students. Many of you will be knowing. Many will be knowing. So that way, you suspend the strip line, suspend the microstrip, non-radiative guide. If you want to have 100 gigahertz or like that, then non-radiative guide will be useful. So these are said to be the few variants. Like that, there are many variants, and its advantages also I have listed. So it is just simply the combination of air and substrates. You can suspend it, or you can invert it, or you can elongate it, or you can do any kind of, that's what we say, variants of the planar transmission lines, multi storage or multi strip lines. Like that, many you can say. Again, using the transmission line equation, how many may be the epsilon r in cascade, you can effectively find what is the value. So that is what I mean by variant. And this is for slot line. And there is a very important difference between the slot line and the microstrip. In microstrip, as the frequency goes higher, the width will become lesser. It will be very difficult to realize that. Whereas in slot line, as the frequency increases, the dimensions increases. So the dimensional tolerance is better in slot line when you compare with microstrip. There's a very old book, again written by Siri Pilani people, Amarjit Singh Gupta, that deals all these things in a very effective manner. So these are the another few things regarding attenuation. First one is ordinary microstrip. Second one is suspended microstrip. Third one is inverted. You can see it is all jugglery between the epsilon effective, how the chicken is getting heated, because of each part has got different epsilon r. Same thing in microwave, D is equal to epsilon E. In some case epsilon effective, some case epsilon r. It all because of its variation. That is why you get different. So combine all the advantages, you will get totality. So now you can see this curve will tell you the attenuation for microstrip is more in comparison to suspended microstrip and inverted. Then inverted has got more when you compare to suspended. So these curves. So what I want to tell is, at least in this short time, I feel that at least I have shown you some of the books. Maybe I will pass it on all the authors' name books also to your coordinator. I have got some more time, another half an hour, and you can reserve your questions that time. You can tell your opinion also. these are all suspended microstrip, whatever it is, whatever you do, suspended, inverted, V groove, all those things you can do for all the planar transmission lines. So you will get the effect of both the advantages. That is the principle of micro electromechanical system, which was developed by Richard Feynman. He at one time he told there is a plenty of room at the bottom. That fetched him Nobel Prize. So this is the effective dielectric constant for one planar transmission line. This is the expression for finding out W by H for microstrip for the other one. This is what you will get. We call it a Wheeler's curve. If you see this, 20 ohms you will have a broader width, and 100 ohms you will have a narrower width. And these colors are for each different epsilon r. From alumina to 2 to 20, you got different epsilon r. One should be able to draw it using MATLAB or Python lab, and you can directly use what will be the W for 20 for that epsilon r, what will be the W for 100 for that. That's why in the filter design you have seen narrower will be for inductor, broader will be for capacitor. And that's how you design even for an antenna LC circuit. That is why the LNW approximately lambda g by 2. Then you should remove the correction factors, and no need of big software which costs 20 lakhs 40 lakhs. Your own students can do it. This is done from MATLAB using GUI. Just to feed all the specifications, finally you will get it. So but you should do it with your theory and by your own hand, then only you can understand the beauty. So this is the cross section of NRD. The person who developed NRD is Yoneyama, still is in Japan. And another thing, miracles of lambda. You should know if it is less than lambda by 2, if it is more than lambda by 2, if it is almost equal to lambda, the effect. So in the equation you put all those lambda, you will know what is its effect. So it is 0.45, 0.003 lambda, it does so many things. NRD play a very big role in 100 gigahertz. Why 100 gigahertz? 300 gigahertz. So as the frequency goes, these are the things: NRD, insular image guide, H groove. These are the planar transmission lines at higher millimeter frequency, terahertz, in your 5G. These planar transmission lines are used. So what I mean to say is, it is not initially it is only microstrip, slot line, strip line. By that, many more transmission lines come into the picture. This is the popular NRD guide, H groove. This spacing, you know, one should be very good. LSC mode, LSM mode, that is also very, very important. And this is one of the device got from NRD mode. And this is one component built by NRD guide bandpass filter in CAR lab. And this is the filters, entire filter in the country, in the world. And what one can see is the discontinuity. You can see, first of all, what you see in the low pass filter is a 3-section filter, 50 ohms line, left side, right side. Then other capacitor, it is a broader line. Then inductor, very thin line. Then capacitor, broad line. Then you can see step up discontinuity, step down discontinuity. Then we have got stub method. Everything is there. And discontinuity somebody can take as a PhD work. It is a ocean. I have completed 16 discontinuities in coplanar waveguide. If you take a TC Edwards, that is the Bible for microstrip. cell phone net to so you can see broadside coupling, end coupling, all those things. So discontinuity itself is a version. This kind of planar transmission line discontinuity you can realize in many transmission lines, every planar transmission lines. And this also, one should not simply use that big formula. Everyone uses the delta L formula, that, but one should know how to get that formula from the Hammerstedt paper. Now you want to join 50 ohms, first of all, in terms of lambda. Our input is 60 lambda by W. You find out the impedance, you match it with 50 ohms by a quarter wave transformer. Take the square root of 60 lambda by W and 50 ohms. That will tell you what is the characteristic impedance. The length is lambda G by 4. So by knowing the lambda, you can go by the design. If single patch is not sufficient, then you can go for array of it. What I mean to say is the impedance alone will tell you all the W length, all the design values. And this is the formula, especially the junior researchers, please note down. I have not shown Maxwell's equations at all. This is, everyone get it in second year of BTech. Voltage at any point, current at any point, divide voltage by current, you will get input impedance. This is for any transmission line. And gamma is alpha plus j beta. We take lossless transmission line where alpha is 0, in which case this becomes a trigonometric equation. From that you get everything. What is ZSC? What is ZOC? One is JZ0 tan beta L. Other is Z0 by J tan beta L. By putting ZR 0, ZR infinite, from here you get ABCD parameter. You get everything, K inverter, J inverter, corona transformation, nothing that you cannot get from this equation. So this is very important. You know it. I am just giving the importance of that. You cannot tell any design which cannot be done with this equation. So you make this hyperbolic into trigonometric and keep developing. And this is many people find difficult to connect, where to connect to find out the feed point. Again, use this equation. And in microwaves, whatever you say for impedance will hold good for admittance also. In the previous equation, you write for admittance. How many may be the layer, simply cascade it and find out where you get 50 ohms. There you connect the feed point. What I mean to say is, layers are no problem. The different kinds of planar transmission line is not a problem. Simply use this method. This method is called a transmission line method. You can understand the theory, come out with many things. And Marconi is not the father of radio, father of millimeter waves. everyone accepted in the world. 60 gigahertz, this person played so many years before, J.C. Bose and Victor Veselago. One should be thorough with the transmission line. Then replace every epsilon or mu or less than 0. That is metamaterial. That was formulated by Veselago in 1967. He is father of metamaterials. And these are nanotechnology. We are seeing colors, metamaterial. You cannot, line of sight propagation, if you want to bend microwaves, that is possible by metamaterials. And the Bible for that is Callas and Ito. And he is the father of MIMS, Richard Feynman. And this is the one. You want to get the benefit of substrate, you want to get the benefit of air. That is the principle of micro electromechanical system. Because of the Miller indices, you get this as 54.7. That is the number you get, tan inverse or root of 2 by 2. Again, you take a book. It is not MEMS used at RF frequency. From the beginning, it is being developed for RF frequency. And the book by Vijay Vardhan Vinay, that is the book, concise book for RF MEMS. There are many more books, but this is the book followed everywhere, a good book also. It is all the outcome of the PhD work done in such people. And one of the author is not ECE person, he is a mechanical person. Where there is a will, there is a way. So branch will not come as long as one is having an interest. So this is the MEMS, and that you design it for RF MEMS. that used for biomedical purpose, that saves the COVID even, many of the things like drug delivery, many things. And this is, if you see the planar version, it is just like any other microstrip antenna. If you see the cross section, then only one will know it is a MEMS. And also the dimension. Here it's all micrometer, whereas in the micro it's all centimeter. So these are the cross section of dielectric waveguide. You can invert the dielectric guide, you can clad it, you can enlarge it, or you can elongate it. Whatever I told for stripline microstrip, extend it for dielectric waveguide. There's again a small PDF material. I will send it to your coordinator. He will distribute it. That if you follow, you can print, you can make many components. This is mainly useful for gigahertz. Our people are suffering, our students, even to do the measurement of 20 gigahertz, 40 gigahertz, where to do 100 gigahertz, 300 gigahertz. So these are the solutions. This is one of the component got from NRD, and dielectric integrated guide play a very big role in higher frequency. Image guide, put an insulator, that's called insular image guide, then put in the other box. So here it may look very big, but it's all very small. You can see it through microscope. And the lambda at microwaves will be lesser than millimeter. So sometimes less than lambda by 2, equal to lambda by 2, equal to lambda. So that plays a very big role. That is the reason why it is called magic T. There is nothing like magic in that. The lambdas make a big role, EHT. If you take a directional coupler, why there is no power coming here? Because there is a two Bethe hole, each separated by lambda G by 4. Lambda G by 4 play a very big role. So this is the cross section of, see here again a coplanar waveguide. It is not even ground supported. And micro machining, you use Liga or surface micro machining or bulk micro machining, then do it. So it is all the fabrication methods that differs. This is again a very good candidate for millimeter waves, fin lines. So we have a wonderful Bible written by Professor Bharati Bhatt. I was the last student of that person. And fin line, one side it is a unilateral, two side it is a bilateral, then edge coupling fin line, end coupling fin line. So for millimeter, one should not go for microstrip, go for fin line. It does so much of magic. Antipodal fin line, one mode to another mode you can change. So this can be extended. And now what is fin line? It is a hybrid mode. Both E and H together, hybrid mode. That's how you can go for hybrid mode analysis. And this is another popular one, substrate integrated. The hottest field is FSS. The next one is substrate integrated waveguide. Waveguide can withstand very high power. Planar transmission line, low power. One is miniaturization, the other one is bulky. You combine both. So the bridge between a waveguide and a planar transmission line is substrate integrated waveguide. We have got KEVU. KEVU has contributed a lot. But we have got Indian KEVU. He is none other than Dr. M.K. Mandal of IIT Kharagpur. They do a lot of work. Many more people are doing, but he was the direct scholar of KEVU. BOSI. So SIW. Again, you should know these holes, few rules are there. It is separated by lambda G by 4. What is the diameter? Everything is in terms of lambda G by 4, lambda G by 2. So you get both advantage, high power as well as the miniaturization. So this is the basic SIW. There's a very good paper, BOSI. I will send that also. And that will give a very good review of SIW. See the lambda. If it is unit element, if it is far less than lambda, it is some other material. If it is exactly lambda, it is one structure, photonic crystal. If it is far greater than one, that forms to another structure. It is all photonic band gap or metamaterial. Everything depends upon the lambda. Then this is a few how to make use of the flexible antenna measurement using the network analyzer. In that only India is slightly different. We have technology. measurement facility that is slightly lesser when compared to abroad country. There it is just like CRO, they use network analyzer and spectrum analyzer. These are the books. You can download it. E-book is available for filters. You be thorough in filters, all other things are in your hands. Mathai. The second is microstrip lines, slot lines, all 4 authors. This is not just for Chandigarh, this is for the whole world. K.C. Gupta, Garg, Ramesh, all are Indians. That book is the Bible. The second one, whatever you want to know about microstrip, T.C. Edwards. This is what I was telling. For Finland, Professor Bharati Bhatt, CAD of that. Then this book many would not have seen. Waddell book. Whatever you want to know about transmission lines, a combined book. Normally, many might not have come across. It is not only symmetrical transmission line, asymmetrical transmission line, of the line, whatever may be the transmission line, if you want to do the analysis on your own, take this book, Transmission Line Design, Waddell book. The second one and the only book for coplanar waveguide, it is available e-book, it is R.N. Simon. And there is another book has come by Wolf, but Wolf also refers a Simon book. The next one and the only book for stripline circuit design, Harley and Co. And Wolf book and Levergata is just like a novel. Anything you want to know in a very lighter vein, you can refer Levergata. Then this is the FSS. I strongly advise the researchers to do work on FSS. Our country will get saved. FSS structure, monk, and we have got a monk of India. He is none other than Shivanarayanan of NAL. My own scholar, a son of a carpenter, he has become number 2 in India. He has been given a title, FSS Man of India. The DRDO Prime Minister, Defense Minister has given him 5 lakhs rupees, not the money. He made radar cross section very small, and a similar process is done in Rafael. And this is the one section of FSS. If you want to know more about FSS, directly contact Shivanarayanan. And my student, victorious student, why I am telling is, in 2 years, he has come out with 12 IEEE papers, and the final thesis went to Boise. Boise is next to, he told, no need of correction. And he returned back and told it is accepted. Why I am telling is, the PhD scholars should do like that, not simply counting the journal papers and no use of the outcome. This is the outcome. This is used in CT. This is used in MRI. Who will save CT and MRI, which is saving many persons from COVID-19? How to shield CT and MRI machine? The FSS will do. The biological effect of metamaterial FS in the medical side is enormous. People are not coming forward. That is why I like Dr. S.S. Patnaik, Joshi. They have done a lot of work connecting with the medical people. So you will come to know when they give lecture. This is the one. The person who is having the coat, even the coat he got for hire, Krishnagant. He got all the 3 chiefs are there, including secretary, internal secretary is there, defense secretary is there, Rajnath Prime Minister. Why I am telling is, his FSS structure earned that much credibility. 2 years he completed. So just to give the importance of FSS, I am showing my last scholar, Dr. Krishnagant, and he is Boise. Boise is the top person in the world next to Kevu. He is that much admiring the Krishnagant. The other person, left person, is the coplanar waveguide inventor, C.P. Wen. And the person who is standing, he wrote artificial neural network for coplanar waveguide with his own coding, not a toolbox. So he is C.P. Wen, he is Boise. Bosie's paper, Kevu's papers will help a lot in FSS and SIW. This person who is standing next to me, tallest person in the group, he is Kevu. He has done so many things in the SIW. And this is the small, in a very big conference, this much only is the strength. For IEEE meeting in Japan. So this is the one, the bridge. Again, we see coplanar waveguide. Why I keep selling coplanar waveguide is every one of you who is interested in wearable antenna, flexible antenna, just see what the ground support CPW will do. GCPW. There also CCPW also is there. Many more variants. But please go through the R.N. Simon's book. You will understand, and also the papers. So the bridge between planar transmission line rectangular waveguide is one and the only SIW, whereas fin line is different. Take a slot line, put inside a rectangular waveguide. That is a fin line. So you have to follow some rules. What should be the spacing? What should be the diameter? That is also in terms of lambda g by 4. That is how you can construct SIW. This see lambda g by 10, 0.1 lambda. So 0.003 lambda, 0.005 lambda. Each lambda, that is what I have written an article, miracles of lambda. So what I mean to say is, if you learn the design by lambda g and also in terms of mode of propagation, you can do wonders. You can make the India shine like anything. That's what our ISRO people are doing. Mars mission, first attempt they won. Chandrayaan 2 lost 1%, we lost. Why I keep telling that is 40% of the circuit in the ISRO machines are planar transmission lines, either millimeter wave. It should be flexible, it should be bendable, otherwise the rigid cannot be used there. So that is where flexible, variable, all those things come. It is not simply textile. See, this is the simple formula. It is all in terms of lambda to be taken care of while designing SIW. This is see lambda g by 5 about designing of one particular component. This is another circuit with SIW. Follow the simple 4 rules. This is the reconfigurable antenna. Again, if you see the cross section, it is a coplanar waveguide. Thin film, you have to modify microstrip and CPW. That is used in the RF MEMS. You can reconfigure it. Kalpana Chawla, Sunita Williams, when they go up, if they want to change the dimension of the characteristic of a dimension, they cannot come down or we cannot go. From there, we can do the reconfigurable antenna. And another book, again, Bharati Bhatt's scholar, that is a book for dielectric integrated guides. Now only people are doing microstrip. When to see dielectric integrated guide, that's a separate book. For dielectric integrated guide, you will know everything about that. So this is the fin line different structure. Antipodal line is very popular one. You can change one mode to the another mode. Then this is another technology. Again, an Indian is shining in NTU. He is Alphonse Arekeswamy, and this is the nanotube. Nanotube antenna is flourishing like anything, and these are all just like a Smithy book, like vendor, this pipe mechanic. In fact, our waveguide sound is like that only. Only thing is the electromagnetic waves will not flow like water. It is having a smooth bend. That is why discontinuity, end discontinuity, short discontinuity, step up, step down, notch, all those discontinuities will come. The anechoic chamber, we have got experts in India who can make any kinds of anechoic chamber, and this antenna cannot compensate, but you cannot have this wherever you want miniaturization. This is the best antenna where epsilon or air is used, but for different purpose, different things. So you go for a implantable antenna or textile antenna, wearable antenna. You should know the properties. So this is the one. When there are 2 dimensions, you should use this kind of nomogram and then get. This is a popular nomogram whenever you go for the couple lines. And I am okay. This is the Q. Q is very, very important. When you go for the MEMS, MEMS has got very high Q. How much? 1,000, 2,000, 3,000. Higher the Q, better the performance. See the waveguide. Waveguide got a lesser one, whereas microstrip has got, waveguide got higher, microstrip has got lesser. So the Q also is very important. Quality factor, high Q, loaded Q, unloaded Q, all those things. So these are the guide wavelength and the characteristics. All these things will give you how to go about it. No trial and error method. If you go from the scratch, you can master the subject and you will be top in the world. And Indians do so many things. So these are all the microstrip, strip line. You should know about the dispersion, discontinuity, shield it. Nothing is like this. You should shield it in a box. Then you should know what is the resonant frequency of the TM, resonant frequency of TE, all those things. So the Bible for microstrip, you all may be knowing T.C. Edwards' book. These are all the expressions. One need not get afraid of that. Just to know how it will look like, how you get it, how a person is deriving. It is from the full wave analysis. So use a computer mainframe and then get all the derivations. See the wonderful difference between microstrip and a slot line. So that way, the dimensional tolerance, fabrication advantages, field lines are very, very important. Coupled lines. You have got magnetic wall, electric wall, open circuit, short circuit, all those fundamental things. If you are thorough, you can keep talking stories like Raghavan. So this is ZOE, ZOO. So simply add one more suffix, E or O, depending upon even mode or odd mode. So now everything, whatever I told, you suspend it. That's how now it's coming, suspended strip line and all those things. Now comparison of, anyway, we have got so many transmission lines. Because of that, earlier waveguide coaxial line will have not died. Those are all still used and will be used. So you should know the fundamental very, very strong. And the best book to start that is Markowitz. Then as far as the design concept is concerned, don't need to go for Collins, don't need to go to Watson. Simple rider book is sufficient to understand the thing. If I say WR90, why W, why R? You look into the microwave 101, you will come out with so many answers. So in nutshell, I would like to say, you can even trap it. If you trap it, what will happen? Spurious modes can be avoided. So that way trapped. So the trap now only I am bringing. Enclosure, the field lines, all those things are very, very important. So maybe I would like to finish it in another 2-3 minutes. So these are all the few components. So see, when you go for these are the importance. You should know what is the need in flexible, variable, compactness, reconfigurability, flexibility, durability are needed. So there you cannot go for the rigid one. That is why your cotton, jeans cotton or whatever it is, the Joshi and Dr. Patnaik have done ocean of work. Your Dr. Balvinder also, you can ask them all the questions. They are the real people in that textile antenna. So this is the need. Accordingly, you can decide what is the frequency. Then you decide the transmission line. And the SAR, everyone knows biological effect of microwaves. And you need to bend and durability, humidity. So the purpose you understand, then accordingly you can choose the antenna. This everyone knows about the antenna on a textile. And also the material, like polymer material and other type of material, the thickness, more than the thickness, epsilon r is very important. More than that, what is the loss tangent? That is also important. So you should refer to the Bible of the materials. Exclusive book has been written by M.T. Sebastian for biomaterials. And there's a Center of Advanced Study of India in Trivandrum, Sri Chitra Tirunal Biomedical Center. So the material to be used for biomedical antenna, they have done a research because it has to interact with the body, on body or off body, whatever it is. So that is a separate section for biocompatibility. You cannot use ordinary RT duride and simply swallow it. And you've got specific material for all those things. So these are all the few fabrications, not I did, I took from NIT. And this is your popular GCPW. You should find out. the literature, you can find out GCPW, CPW, and these are the precisely what GCPW does. Versatility, design flexibility, better isolation. Why design flexibility is, you've got so many dimensions. Anything you can change, you can bend it, you can support it, you can have a side walls. That is what is meant by design flexibility. You need not have hairline thick material. You can design value which can be fabricated. So versatility, so you can bend it. So with all that, there should not be coupling. So you should have an isolation. That is where insertion loss, isolation, that formula is very important. So this is all few cross section of ordinary CPW, GCPW. Other than that, there are so many things. Elliptical curve, then ordinary curve. This is edge coupling. Now there are two structures: edge coupling, coplanar waveguide. Now edge coupling, conductor backer, GCPW. So normally you might not have come across CPW antenna, but this is one such antenna. But this is not CPW is a good feed, but not a good antenna. So each are good for certain things. So whichever planar transmission line you take that respective book, and then start working. So this is the CPW. Then you support it, ground supported CPW. Then go for there are so many, whatever you say for strip line, all those circuits are there for CPW also. Amplifier octave, this is not for this alone. Only thing is the frequency is different, usability is different, but the mechanism, common mechanism is same throughout. So these are all the few things. I think I should not test you further. With this, I would like to put a stop to my talk. If everyone is not having a chance, you can send me mail. If it is pertaining to this work, I will just answer. If you want to discuss, maybe 5 minutes, you can ask me a question. Anything you want, you can tell. So final two things I want to tell, especially the young researchers: directly don't go to the software. You write your own coding, come out. And those who do not have the facility of network analyzer, all those things, come for the computation, computational electromagnetics. You see the Ito book, master anyone method, use it, use your MATLAB skill, Python skill, and come out. Papers will come. No paper will come into plagiarism. And write your own coding and come out with societal usable research outcome. What this Joshi and Dr. Patnaik did, people have invited, come and write chapters in our book. What Balvinder Singh written, people have asked many things. So that way make the people, even what my student attained, I did not attain. The moment he developed the FSS structure, first time, Fibonacci structure, first time in the world, Defense Secretary called him and told, Defense Minister called, only Prime Minister did not have time. Why I am telling is, microwaves, we are number one in the world as we are in these space applications. So let your work do some remarkable work, and let it bring pride to you, your institution, and finally to the country. With this, I will put a full stop and thank my dear friend. I am meeting Dr. Balvinder Singh after 10 years, and a wonderful group. And that director is one of the ethical vice chancellors of India. This is being a common platform. I do not want to say why ethical, because rule is rule for him, and he is one of the very few who is master in certain subjects. With this, I thank every one of you for the patient hearing. And somehow I managed about this online. Generally, I don't like online. I think most of the slides were visible, but for few disturbance now and then. I'm very happy to meet. Others I did not see. I never thought I will meet MEPCO. Why I am telling MEPCO is MEPCO has got donation from Agilent, Hewlett Packard. The way in which MEPCO principal Dr. Arivadagan is performing, or Dr. Silva Kumari performing, they got 1 crore fund for establishing microwave lab. They are number 2 in electronics in Tamil Nadu, and number 1 is Tyagaraja College, and they are competing each other in microwaves. I do not know about other participants. I am sorry, I did not meet you. I would like to know. Now I have come out of the PPT. I can see some of you. I thank once again Dr. Balvinder Singh. Anyone wants to discuss can discuss. Okay, before people come for a discussion,
Thank you, sir. Thank you.
Dr. Shanta Shelva Kumari, happy to see you.
Thank you. Thank you so much.
And anything Dr. Balvinder Singh to say, you can say, then it can be open to participants.
Yes. Thank you very much, sir, for delivering so motivating, so inspirational lecture. So you have rightly said that all the researchers should focus on own coding before going to the software. So you have very nicely explained various transmission line concepts. So I am sure that these are going to be helpful to the researchers working in the fields of antenna. So sir, we are feeling very lucky to hear from you. And I am thankful to this technology also. Otherwise, it may happen that due to such large distance, there may be difficulties in connecting with so many of people. So we have more than 100 participants in this FTP. So thank you very much for sparing your time and taking efforts for sharing your expertise with the participants. So every time I feel very lucky to hear from you, to learn many new things. So these things are going to help us in future. Thank you very much, sir. So now I ask the participants if they have queries, so they can unmute themselves, and one by one they can discuss with us, with sir.
I am able to see Professor Vikas Jain. He is from which institute?
Vikas, unmute yourself.
You please unmute.
Sir, your audio is muted. Unmute your audio, sir.
Because your audio is not unmuted. Neha, can you unmute Vikas? So we are not able to hear him.
Okay, any other questions? Anything you want to comment about my controversial statements? My controversial is, without Maxwell's equations, by the input impedance equation, you can do everything. And again, one can take a very easy book, Rider. First half is lumped network. Second half is distributed. If you can represent the distributor in the form of a lumped one, that is what a T and pi, inductor and a capacitor, can be designed. So that way, that's why I keep telling, you can understand the whole thing. Then you can go for higher books.
Sir, there are some questions in the chat. So if you allow, I can read.
Yes.
Sir, there is one question. Can you please explain how you are preparing the masks? See your slides with the red colored masks. So in the slides, you might have shown certain masks during the fabrication.
Okay, it's a nice question. That is how we do the fabrication. I already told the dimensions are very, very important. When you go for the dimension design, you will get 0.234 mm. How to draw 0.234 mm? So what we do is we multiply it by 1000 times. 434 one can draw. So that is how we draw the whole layout. Then after drawing it, you can reduce it by 1000 times. Then accurately you will get the layout. So before getting that in the fabrication point, you should draw it. What you see red color, that is called litho, red litho paper. That is the popular method of fabricating. And you should make in computer all the design layout, either using MATLAB or Python. Draw the layout. It is only the length and the width you have to draw. You should draw it very accurately. Then afterwards, you can transform. There are some few places like institution wise, IIT Delhi has got this fabrication technique, and corporate wise, this one. ISROs, SAC Ahmedabad, ISRO Trivandrum, all ISROs have got fabrication facility. ITI, Telephone Industries, and few people have come out. Incidentally, I should thank the person who asked the doubt. There is a person who does the fabrication without big things, with ordinary iron box, fan. With that, he is doing all the fabrication, and he is no other than the brother of Professor Bharati Bhatt. It is called the company called GB Technology. They do all the MIC components by ordinary technique, but the dimension is very important. So that way, in an easy method also, people are doing. Likewise, you are going to get one speaker, Kumar. He is going to tell how to get flexible antenna, wearable antenna with ordinary gadgets. So the person, the red color is called red litho paper. That only will be superimposed on the RT duroid and remove the unwanted thing. Put the connector left side, right side, you will get the low pass filter or a band pass filter. So this is the, and very frankly talking, those red litho paper are designed for S band. That is not designed by Raghavan, it was designed by Professor Bharati Bhatt. Yes.
Yes, sir. Thank you very much, sir, for so elaborative answer. Sir, next question which I could read is, could you please tell us more on effect of wave on human body?
Okay. This is what I told. So now this is a very nice question. Now I will ask the same person one question. I will also answer the question. What question I want to ask is the 5G affecting COVID-19? Or if I ask, that will become a controversy, because one country started 5G, that time this also came. I will leave all those things. But you take your cell phone, keep in your ear for 6 minutes, your ear will become reddish. So now the best way of using communication is using landline. If you use landline communication, no bad effect. Now, cell phone, if you have, now the person who asked me the question, please go to Yahoo or Google and type cell phone tower radiation effect Girish Kumar. You will get so many disease name. So the cell phone are said to be 21st century cigarette. In cigarette, at least you can see the smoke. In cell phone, you cannot see. You do not know the harm. You cannot see the harm. So if it is so, when it is a lower micro frequency, you can imagine what will happen in millimeter wave frequency. So definitely it is harmful. The same question you ask when Dr. S.S. Patnaik is going to give a lecture. He has been a postdoctoral fellow on this topic under O.P. Gandhi and worked on Nokia machine. In any case, higher the frequency, worse will be the biological effect. It can heat. So can it be kept on the heart? Will it not get heated? So many things, even memory power will go less. I should not, this is happening even for a lower frequency. So what will happen in the millimeter? So this is coming a separate version. It is coming under the category of biological effect of microwaves. You should know the epsilon r of each part of man, each part of woman. To be very frank, I can tell microwaves will not harm women comparatively, but microwaves will harm man. Or I can say, if a man cooks with microwave oven, some reverse effect will happen. If woman cooks with microwave oven, it won't happen. So it is all due to epsilon r. Anyway, this is a topic under biological effect of microwaves. So you take O.P. Gandhi book, a few of the general papers, epsilon r, then you will get correct answer for this millimeter wave on biological effect.
Okay. Thank you very much, sir. Dear participants, if you have any other questions, you can directly ask sir and unmute yourself. Sir, there is one question: how to select substrate dimension for CPW fed microstrip antenna?
Oh, as I told in my talk, I told CPW is not a good antenna, but CPW fed antenna is good. So that's what that person has chosen, CPW fed microstrip. So now you should see the application and also see the frequency. And very few materials only are there. As long as you don't go to flexible antenna and variable antenna, what material we have got is RT Duride, alumina, Teflon, and FR4. And if you are from any good organization, or if you can write a nice letter to Roger's trademark, and if you say that you are not doing for commercial, it is for research purpose, they will send a very big size of RT Duride. You can do some 10 components. So that way, otherwise it costs 30,000 rupees. So if money is not a constraint, I strongly advise to go for RT Duride. Because of money constraint only, people go for FR4. It is very cheap. So that way also money also decides. But when ISRO or defense is there, money will not come to the picture. The final outcome only. So that one have to select only between these 5 materials. If it is flexible, another thing, there are many materials. So that is to be decided on the outcome of the performance required. But if it is to be swallowed, then some more care. It should not have the side effect in the body. So that way, biomedical antenna, it should you should take care of the biocompatibility. Such material only you should select. So there are 2-3 good books, I can say Bibles for materials. You select that. It is nothing like a CPW fed microstrip antenna. Anything can feed, but it depends upon what is the main antenna where you are using. So as long as it is not flexible and variable, we have got only very few, 4 or 5. Within that, you select it.
Thank you very much, sir. Sir, there is a next question. How to measure dielectric constant of any fabric?
Okay, we have got one formula by the quasi-static approach. You find out the capacitance with air and capacitance with dielectric. With air means no need to introduce air. You remove the dielectric, that means the capacitance with air. That ratio is called the epsilon r. And if you are interested in any particular frequency, then it is called epsilon effective. So this is the easiest method. But if you ask the core physics people, they will tell you especially in Chandigarh, you got CISF. In CISF, you need not go up to CISF. In physics lab itself, you got a dielectric measurement facility needed. So that setup you can get it. But in short, principally, it is the ratio of the capacitance with air and capacitance with substrate. Here you are telling about the textile. So with the textile, you make a known size. So you can find out what is the capacitance. Then you can find out the capacitance without dielectric. Take the ratio. That is how you can compute. As far as the measurement is concerned, directly. For a minute, I saw Dr. Joshi.
Yes,
Dr. Joshi, just now I saw his face. Yes. And when he is giving lecture, I request the participant not to leave him. You bombard him with all questions. He is one of the popular persons in textile antenna. real textile antenna person. He and Dr. Shyam Patnaik and Dr. Balvinder. I felt happy when I saw for 1 minute Dr.
So,
Joshi. Any other
Dr.
question?
Joshi, if you are there, would you like to say something? Dr. Joshi,
Yeah.
are you?
Dr. Joshi? Dr. Joshi, Dr. Balvinder, students should ask, participants should ask, and also Dr. Shanta Shelva Kumari, what are the testing period you had during your research time? They all came out. All those testing period, that's why now they are successful people. So I also faced lot of testing periods and have come out. Dr. Patnaik also. Many of the successful people have faced a lot of testing time, and these are all the people. They are success today only because they faced their testing time. Is Dr. Joshi ready to talk one or two sentences?
Dr. Joshi, unmute yourself.
Yes, come. Everyone is able to see Dr. Joshi.
Yes. Good afternoon,
Before
sir. Good afternoon, all the participants.
Before Joshi talking, I want to tell the participants, go to Yahoo or Google, simply type Dr. Joshi, Dr. Patnaik, textile antenna. You will get a popular IETE journal paper. So now I request Dr. Joshi to give one or two sentences.
Good afternoon, sir. Thank you.
Yes.
Yes, tomorrow I will be presenting my work, my PhD work into the presentation. Sir, am I audible?
Yes, I am enjoying.
Yeah.
I am enjoying your talk.
Yeah, sir. So, in the tomorrow afternoon session, I will be talking on different variable antennas, their fabrication techniques, and different substrates used. That I am going to present on tomorrow. So I will be giving some concepts on metamaterial antennas, testing of variable antennas. That part I will going to cover on tomorrow. Hello.
Okay,
Sir,
nice.
sir.
Tomorrow,
Thank you.
participants will take all the benefits of a wonderful speaker on textile antenna.
Sir,
Okay.
So,
I requested Balvinder sir to attend your particular session. That's why I am in your session, sir.
Thank you.
Sir, very nice to see you, sir.
Okay, I am seeing one more person, Mithun Jai.
Sir.
No,
Yes,
somebody,
sir.
Sunil Sharma. Okay, thank you, Dr. Joshi.
Thank you, sir. Thank you. Good day, sir.
Sunil Sharma, I am able to see. Anything you want to tell? Anybody else?
sir, some of the participants are typing in the chat. I think
Okay.
they are not.
Okay, Dr. Bharanidharan,
Yes.
he is asking about discontinuity. So discontinuity, just like nuclear fission, you can make it. Dr. Abdul Kalam got benefit because you use the nuclear fission for an important thing. Likewise, discontinuity is not a bad thing. Using discontinuity, you can think of designing components, step up discontinuity, step down discontinuity, notch discontinuity, strip discontinuity, bend discontinuity. You should find out what is the equivalent diagram. Once you find out the equivalent diagram, using that you can develop design filters, you can develop antenna. So the discontinuity can be effectively be used for designing components, especially in some planar transmission lines. Discontinuities have not come in the journal paper. When I completed my work 20 years before, not that much discontinuity. So 16 discontinuity on coplanar waveguide. Once you start it, automatically another discontinuity will come. So I did it. Whereas if you take TC Edwards, all the discontinuities of microstrip is there. So there are some few planar transmission lines, discontinuities have not been touched upon. So those who are starting, you can think of. So in this aspect, I would like to tell the book to be referred, is that Markowitz. Markowitz, in that book, waveguide book, he has told how to deal the discontinuity analysis. The same thing you refer to the different planar transmission line. You will also be a successful Markowitz. Anything not in the regular stream, sudden change, that is what people say discontinuity. It can be step up or step down, notch, gap discontinuity, all can be effectively used. We have got only two elements, either as an inductor or a capacitor or a combination of that. So if you understand both the side, you can come out with some new happenings.
Sir, there are two more queries in the chat. So
Yes, sir.
So the first query is, can you please elaborate about smart pills?
Oh, okay. The smart pill, it has got another name called microwave pills. What I showed, that was the one existing around 30, 40 years before in some of the research labs of America. And I'm just giving you an overview. So none of you, please don't try that. It is not available also in India. And why I showed is, it has got the cross section as a coplanar waveguide, and this come under the category of biomems. Even in COVID-19, people are not releasing vaccine because they have to take care of so many things. Even though vaccine has been found, they are all doubly careful in not releasing. But what I told has got a simple capsule like thing only, exactly the same size. So it has got three compartments. One is the antenna, which will transmit ECG, EKG, ERG, all the physiological signals, and the transducer. A person can swallow it, and it will come out the next day like any other particle. But as it goes around the footpath, it will pass on the signals. The referral hospital that will receive ECG waveform, EMG waveform, all those things. Then the doctor can diagnose. We are very good, top in the world about the telemedicine. So we will receive that, and accordingly the doctor will know. We will do the diagnosis. If necessary, he will instruct the ordinary doctors, not specialty doctors, to do what further thing. So that is what is called the smart pill. It has got another name called micro pill. If we say whether I have seen, I can only say it is in the. I know that theory when I was doing MTech 50 years before, but it is in the laboratory of some of the advanced biomedical center, not even India, because in India the drug delivery is there. If you go to Amrita Hospital, you can see drug delivery system that you can physically see how to release the medicine uniformly even during the night time. That is, you can see. Likewise, there are few things. Telemedicine, Madurai, Aravind Eye Hospital, that is number one in the world. Sitting in Madurai Hospital doing all therapeutic diagnostic work of a village student. So few you can see in India itself. But this is the example. Still vaccine has not come out, even though vaccine has been found out. They want to take all care, and then only they want to release it, because it is something with life and death problem. So in any case, since you asked the doubt, I am telling about the smart pill. And my interest here is the cross section of a smart pill. Biomems is coplanar waveguide. CPW, microstrip are the only two planar transmission line used in biomems. Incidentally, that is a good topic where you can finish the PhD quickly. If you have some persons who can help you from PGI Chandigarh or AIMS Delhi or JIPMER Pondicherry. So if you have that much of cooperation, you can take this work. It will be useful for society. Biomems.
Thank you, sir. Sir, there is one or two more questions. So if you allow, then I can ask. So I have already taken your much time. So if you can share a few minutes more, then I can ask.
Yes, 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 yes. As long as participants are there, I am ready.
So nice of you, sir. So nice of you. So, sir, they are writing in the chat. So, the one question is please suggest how to obtain dimension of antennas for different application using optimization techniques.
Okay. See, he is asking the dimensions of an antenna. So the antenna has got another name. It is called resonator. So in the equation what I gave, input impedance, if you put L is equal to lambda G by 2, you will get this expression, ZS is equal to ZL. So if you take any antenna, the length and the width, the dimension is lambda G by 2. Lambda G, why I am telling is it is equal to lambda naught by root of epsilon effective. If it is a variable textile antenna, use the epsilon r of textile. And also see, so that way you can find out guide wavelength. Then that divided by 2, that is the design dimension of length and the width. Now we have a term called fringing capacitance. Because of fringing capacitance, you won't get the theoretical value. It won't be exactly lambda G by 2 length and the width. So what you should do is, you should subtract correction factor left side and right side. And that also everyone, there's a paper by Hammerstead, and that will tell you what should be the exact value of delta L for the particular frequency and particular epsilon r. That value should get reduced from the length and the width. That is why if you see a patch antenna, the length and width are not of the same dimension. It is slightly, one is slightly more, one is slightly less. Approximately it is lambda G by 2. So that is what you do. Now you asked about the optimization. So now what you do is, now as one person asked about the discontinuity, because of the discontinuity, what you theoretically get and what you really measure, there is a variation. That is mainly because of the measurement problem or soldering problem or the material problem or discontinuity. So in that only, now you can go for your optimization. So now what you do is correction factor, all those things. Now you go for optimization. There are many optimization techniques. And then instead of simply lambda G by 2, see what correction factor has to do. So this is where optimization will help. So you may ask, if there is no software, what I will do? If there is no software, in 1960, were there software? All those big things came that time. So they were patiently sitting, they were doing all those things. Computers were inside their mind. They are all very good in conventional mathematics. They did on their own. But now what students are doing is trial and error method. Now that they got 1 year for project work, they keep on trying. Suddenly they will get the result. But in that time, your optimization will help. It will pinpoint to a correct design value. In general, antenna design is not a big thing. It is simply lambda G by 2. Now you should take care of the discontinuity, take care of the correction factor, and then finally go in the optimization techniques.
Thank you very much, sir. Sir, I think the question which I am going to ask is that will be the, I think, last question of this session. Because there are no more questions. So last, sir, this question is, which book you prefer to draw an equivalent circuit for FSS?
Which book?
Yes, sir. Which book you prefer to draw an equivalent circuit of FSS?
Okay, this is a very, very nice question. Can I know the name of the person who asked that?
Sir, yes. So, sir, this is asked by the participant Sakti Abhirami.
Okay, Shakti Abhirami. Okay. See, she asked a very nice question, because it is not only FSS, anything you take, first thing one should draw is equivalent diagram. Now, she has asked a really nice question, but a tough question. And the book to be followed for drawing equivalent diagram of FSS is, there are 4 books, 2 books by Monk. And one is the fundamental one, conventional book. another book by Array, that is also by Monk. Though these two books are good for equivalent diagram. There is another book by Wu. It is not K Wu, it is T Wu. So that book is also good. Then there is another book, practically an Indian. I call him as Monk of India. He was the guide of my student, or you can call Krishna Gandhi. His name is Dr. Shivanarayanan. His book is also good. Above all the things, I want to tell, maybe Dr. Balvinder, maybe knowing him, I have forgotten his name, maybe I will send the mail ID. He is a professor in Kurukshetra University. First time I have seen that person coming out of the equivalent diagrams of all the FSS structure. He is an associate professor in Kurukshetra University, not IIT or not NIT. He is from Kurukshetra University. I will send the name to Dr. Balvinder Singh. He has come out very clearly the equivalent diagram of all FSS structure. And there are some good papers also on equivalent diagram of FSS structure. So with this, I am sure that Abhirami will be able to get the equivalent diagram of the FSS structure. I hope Shanti Abhirami is doing work on FSS. If anyone is doing on FSS, definitely in 2 years one can finish. That paper will be accepted immediately. You will get a very good name.
Sir, with this,
And another name for FSS is, it is a big name. It is also a spatial filter. It did not come today. It came from Marconi. Marconi's patent, Monk developed in 60s. And that only has been developed further by Kevo, a very young person. And so one day Abhirami will become an expert in FSS. So you can think of, is it my own student? He's a very poor person, but rich in academic. Krishna Gandhi is number 2. And within 1 year, he'll become number 1 in the world. That's how he is speeding up and making his work usable for the society. Society means what? Defense. It can be directly be used in the space shuttle. Anyhow, before winding up, I thank all the participants for giving me extra talk of half an hour. If I had extended 4 o'clock, people would have got angry. By the method of asking questions, you gave an opportunity to talk further 60 minutes more. I am very happy that I could see many of the persons known to me, maybe especially Balvinder Singh. After 10 years, I know all the obstacles, what he faced. Obstacles means what? Academic obstacles. And you are so fortunate that he is having wonderful guru, Dr. S.S. Patnaik. And last thing I want to tell, while reading biodata, Dr. Balvinder Singh told Raghavan is a professional society member in more than 24. It was because of Dr. S.S. Patnaik I became senior member in IEEE. Now I am expecting to become fellow, if everything goes on well, in another 1 month. So I owe a lot to very young person. Compared to me, Dr. Patnaik is very young, and Dr. Balvinder and Dr. Joshi are children for me. So that way, Dr. S.S. Patnaik has gone to a height. His brother R.K. Mishra is doing wonder. So anyway, very happy. I had a very nice time. Thanks to Dr. Balvinder Singh and all the participants. Thanks a lot.
thank you very much, sir, for your valuable time and generous time. So you have answered all the queries of the participants. So I'm very thankful to you for accepting my invitation and sharing your expertise and sharing very practical things. So because your advice of not directly going to the software, so this is very useful. Even when I started my research work, I visited NIT Trichy for the STC conducted by you only. So at that time, you also advocated this idea, and me and Josie both were the participants of the SSTC, and we kept on trying many things without the software. So that's why we got some good results also. So we are very thankful to you for providing guidance at that time also, which shaped our research work. And I also request the young researchers to follow this advice very seriously, because if we are understanding the things which are working behind the scene and which are actually happening, so that gives us a very good understanding of the subject, and it is very helpful for developing many new designs and many new applications. So thank you very much, sir, once again. So I will be in touch with you through phone and email. Uh, Thank you very much for joining the session. Thank you very much once again. So with this,
Okay, please give me 2 more minutes. I just
you are
want to tell.
welcome, sir. Welcome.
Before the birth of Balvinder Singh, Dr. Patnaik made IE3D to come to the NITTR. Of all the NITTR available in India, NITTR Chandigarh alone is devoting more time, more money, more effort for microwave related thing. That is how people come out with this textile antenna, and that is because of PGI. They have got a good interaction. 3 medical centers no one should forget. One is PGI Chandigarh, other is AIMS Delhi, then Jipmer Pondicherry. They are doing wonders in life saving. So Dr. Patnaik has got lot of relationship with all those people. Then many things what NITTR, other NITTR is not having, because NITTR is mainly to teach others how to teach. They are not for developing microwave, but because of the special interest, enormous growth. If you have a chance, I wish, with the help of Dr. Balvinder, please visit the TV lab of NITTR. Have a good interaction with the real human of the world, Dr. S.S. Patnaik. There are many reasons why Raghavan tells about Dr. Patnaik's human value. Even today, he is not coming because once you become vice chancellor or once you become director, your touch with the academic will be lowered. Otherwise, he would have been the first person to come here. In any case, I request all the participants to interact with him when he gives lecture and see and get to know from him the success story. You will definitely finish your PhD, come out with wonderful papers, and very few in India are like Dr. Patnaik. So I need not say how is Balvinder Singh or how is Joshi and many more people. Thanks a lot.
Thank you very much, sir. Thank you for your time and effort. So I think now it's time to wind up the session, as there is no more query from the participants. And I am sure that all the participants have got great knowledge from your session, so which will be very useful for them in their research work and in their further career. So thank you very much, sir, once again from core of my heart for accepting the invitation. And also I thank you for arranging other experts also. So many of the experts have been arranged by you. So I am virtually the coordinator, but actual coordinator is you only, sir. So you suggested so many names and you arranged the experts, so which will be sharing their expertise in coming days also. So I am thankful for your lecture as well as for arranging the experts for my this FDP, sir. Thank you very
Thank
much,
you.
sir.
Thank you.
Thank you, sir. Yeah. So, dear participants, with this, we are closing today's session. So, those participants who faced any difficulty in joining the link, so we are working on the those technical issues. So, probably we will be sharing the new link in the evening, and you will be able to join using that new links, which will be shared in the evening because of certain technical issues in joining in this link. So I will be sharing that link with all the participants. Sir, I will also share that link with you, the new link which we will be created. So we will be shifting to a new link from tomorrow onwards. So hopefully that new link will not have any technical issues for the participants while joining the sessions. So with this, uh, I think it's now time. So let's wind up the session with many thanks to Dr. Raghavan for his valuable time and efforts for sharing his expertise. Thank you, one and all.